Welcome, everyone. This is an event of the Environment Forum, which is run through Harvard's Mahindra Center for the Humanities. I'm Sara Dimmick. I'm an assistant professor in English, and with Robin Kelsey, who is here, I co-organize the Environment Forum. We are absolutely delighted to have Sara Grossman with us tonight. Sara is an associate professor of environmental studies on the Johanna, Alderfer, Harris, and William H. Harris Professorship in Environmental Studies at Bryn Mawr College. She is a poet, an environmental historian, and a seed saver. And this spring, she and her students are making dyes from plants, including eucalyptus, cabbage, hibiscus, and blackberry. It's one of those classes I wish I could take myself. Sara's incredible book of poems, Let the House of Body Fall, was published by the University of Chicago Press in 2018. And for those of you who haven't had a chance to read this collection yet, the poems reflect on the persistence of the non-normative body, the evolution of post-industrial and chemical landscapes, and the existence of human life beyond carbon economies. I will also say that I have taught Sara's short essay on disabilities, which was published in the Living Lexicon for the Environmental Humanities and is available open access online, again and again, in a course that I teach here on toxic rhetoric. I see a few of my students in the class here tonight. When I ask students at the end of this course about which pieces of writing will stick with them from the semester, I often think they will mention Rachel Carson or perhaps Helena Maria Viramontes, but more often than not, they name Sara's piece. But tonight, we have gathered to hear about the research and thought that informed Sara's first scholarly monograph, Immeasurable Weather, Meteorological Data and Settler Colonialism from 1820 to Hurricane Sandy. It was published by Duke University Press just this past August, so we are very fortunate that Sara is here already to tell us about her work. In this book, Sara ranges through 2 centuries of American history and meteorological data, demonstrating how scientific institutions used weather data to construct and reinforce a white patriarchal settler society. Sara's chapters raise questions that should be asked more often than they are. Does the drive for data injure rather than inform? Is the impulse to measure more about ownership than knowledge? Whose data counts? I will let Sara usher you into the particular archives and histories that address these questions, but I want to close by reiterating that this book could not be more timely. In Sara's words, all the data in the world will not be an elixir for extreme weather, environmental collapse, and climate change. We're also grateful that you have traveled to join us tonight, Sara. I'm in awe of your work, and I suspect that by the close of your talk tonight, that feeling will be shared by everyone in this room. Please join me in welcoming Sara Grossman.
Okay, can you hear me all right? Great. Thank you so much, Sara. Thank you to Mary and Robin for helping to organize this visit and making it possible. I want to point out before I begin that if you need to see a closer up view of any of the captions on my slides, I have an accessible copy of the talk on my site listed here. Please don't circulate or cite from this material. It's really just meant as a way to have folks follow along if that's what they'd like to do, and also to see some of the captions close up because they're a little bit small on this screen. And of course, we also have the live caption, which will not be perfect, but it is usually at least 60% correct, if not more. And so as Sara said in her introduction, I am also a Sara, and I am an environmental historian and a poet, and I'm here to talk today, as was mentioned, about why all of the data in the world has not saved us. You will rightly wonder after that sentence what I mean by data and who exactly is included in the us here. These were central questions that drove research for my first book, and that's the book that this talk will be grounded in today. Generally, my research focuses on unruly matter, from extreme weather to post-industrial environments, from medicalized bodies to storm surges. I'm curious about how immeasurable phenomena are mobilized into data and for what purposes, or how seemingly immeasurable matter and experiences do indeed get measured, and the forms of relation that are possible through such moves. Today, I'll talk specifically about 19th and 20th century US meteorological data. And by the end of the talk, I will be tumbling through that word meteorological. It's a tongue twister, so bear with me. And the impact of this data capture on notions of environmental relation, nation and belonging, and the effects that data systems have on recognition of the biosphere as a braid of lifeways that includes also us. I'm particularly interested in how the data of climate crisis is both a hard material and a symbolic force, and how it is developed and depends on 2 centuries of what I've called weather-dependent settler colonialism. Today, I'll begin by talking about the fact of land possession and settlement in the 19th century, and how both of these moves are important dimensions that made weather data collection possible in the United States. Of equal importance in this early period in the 19th century, exploring the epistemic foundations of data, is how meteorological science furthered the dominance and conquest of Haudenosaunee lands and lifeways in the northeastern region, creating what Kristen Simmons terms a settler atmospherics, which has come to structure data-driven worldviews and the data of climate crisis into the 21st century. That will take us into the second section of the talk, which is grounded in the 20th century and focuses on the technical regimes of data collection. Here I'll speak a bit about data-driven meteorological satellites and how they furthered nation-state partnerships and normalized meteorological technology for the purposes of resource extraction, from oil and gas to weather brokerage insurance markets. I'll finish up really briefly today by talking about living with the particulate matter of data in the 21st century, what it means to live with these legacies, and specifically what to do with the bad weather we've inherited. The data of climate crisis is real. This talk in my book is not grounded in suggesting that all data is bad, but in encouraging us to think about weather data specifically and environmental data, perhaps more generally, as a product of a 2-century-long investment in counting, over interspecies care, in atomized data portraits over the messiness of relation. Our future needs both of these things, both weather data and a way of thinking about enmeshed biospheric systems, but the balance between them, history shows, is off. It had just begun to rain when Ithaca Academy professors S. Finney and X. Haywood walked outside of their academy office and stood in front of a hole they had dug in the ground. Occupying Cayuga land, as the academy had since its incorporation in 1823, Finney and Haywood began the process of measuring the rain. They placed a hollow cylindrical vessel in the ground and waited for the rain to end. After it stopped, they measured in inches the amount of still water that had collected in the vessel and recorded this measurement in a book of 24 folio pages, foolscap size. Finney and Haywood repeated this process every day that April, measuring rainfall, but also temperature, wind, and sometimes cloud cover, until the entire month had been recorded. The rain made it a busy month. Shad, currant, plum, and cherry all blossomed within a week of one another, and the barn swallows made their first appearance the very last day of April. The year was 1827, and across the lands of New York State, settler meteorological networks grew, with 34 stations that extended as far as Ontario and as far south as Jamaica, Queens. Professors and their students used folio books to design their monthly forms and yearly reports, which included monthly averages of temperature, records of wind direction and rain totals, and also these other miscellaneous observations, such as the first daffodil bloom, and one of my favorites, which is the disappearance of ice from waterways. In January 1829, Finney and Haywood sent all of their observations from the previous year to Joseph Henry, who ended up in the 1850s being the first secretary of the Smithsonian Institution, and T. Roman Beck at the Albany Academy in New York State. Henry and Beck were responsible for organizing and calculating the observations from Ithaca and 33 additional Academy offices into a set of meteorological abstracts that would be published in the annual report of the New York State Regents. The story of these two volunteer observers and their daily routine in the mid-1820s reveals how data was conceptualized and activated through the social life of settler science. As part of a regional network of newly titled weather observers, and they very much liked this title, they would refer to themselves in the third person in some of their letters. This network of weather observers across the northeastern United States, the story of our two observers in Ithaca also reveals how weather measurement upheld settler desires for territory by building proprietary claims to place through archives of settler environmental knowledge. Data collection in this period grew out of land surveying. Collecting national data meant extending and occupying often unceded territories. The network of observers who furthered settler surveying and data collection included members of institutions such as the New York State Regents, which I've mentioned, but also the Franklin Institute, Girard College, and the Maryland Academy of Science and Literature. As settler volunteers around the eastern US collected daily weather observations, they created an origin story for settler environmental knowledge. Over the course of the early 19th century, these observations would become a collection of regional meteorological data points. Here's an example of a slide that it's really hard to see what is in it finally. So if you want to get a closer look, you can do so on the accessible copy. By the late 1820s, roughly 49 academies from across the state of New York were involved in daily weather observation. I'm going to linger on this for a moment. 4 years before Finney and Haywood sent their observations to Albany, in 1825, the then vice chancellor of the University of the State of New York, Simone DeWitt, met with the Board of Regents to propose a statewide meteorological observation project. He submitted a resolution for statewide observation and it was passed. The statewide network distributed funds for scientific instruments such as thermometer and rain gauge to the state academies. So observers didn't need to pay directly for these instruments. And academies across the state received instruments or purchased instruments and were able to undertake daily, monthly, and yearly weather observations across the state. This observation required, among many things, continuous settlement or continuous occupation. Creating one of the first statewide networks for weather data collection, collation, and publication, as well as managing the material and graphical output of observations themselves, hinged on land possession. In its earliest manifestations, the power of data lay in its capacity to solidify what land surveying proposed, that European settlers could claim land. As Finney and Haywood, as well as Henry and Beck show, they sought to measure, study, and archive the land, turning land into a resource to be studied, measured, and used for world building. Weather collection not only literally engaged unceded territory, but also actively laid claim to it through settler science. Settlers had been occupying the main tract of what is now known as New York up until the Revolutionary War and began squatting across the homelands of the Haudenosaunee by 1775. The Haudenosaunee were and are an alliance of native nations, including the Cayugas, Mohawks, Oneidas, Onondagas, and Senecas, that reside in New York State and present-day Ontario. In his actions as Surveyor General for the Continental Army during the American Revolution and the state of New York from 1784 to 1834, Simone DeWitt, who we may recall was involved in proposing the first statewide weather observation network, was also the party responsible for apportioning the homelands of the Haudenosaunee to settlers for permanent occupation. In coordination with his cousin, Moses DeWitt, who was a land speculator, Simone surveyed and mapped the way for land possession in the late 18th century and early 19th century across New York. From 1784 to 1835, DeWitt was a key figure in apportioning and visualizing settler claims to land. We can see this is one of DeWitt's maps, which does the work of apportioning and visualizing the work of surveying. So he was involved in this apportioning and visualizing settler claims to land, working with army captains who trespassed on Haudenosaunee Confederacy lands to survey, quote, the lands apportioned to the troops of the state. These surveys formed the basis of European land claims and paved the way for the settlement of residents of the state. Surveying traveled hand in hand with weather data collection at the turn of the century and throughout the early portion of the 19th century. DeWitt is a key figure in this history of settler data, both because he helped to build the state's land possession infrastructure and because he proposed the first statewide meteorological network, one that would build upon an already existing network of military fort structures from 1812. And oftentimes military forts were also meteorological outposts for the Army. The land that DeWitt apportioned to settlers is here, set beside a list of meteorological stations across the state. The first map documents a land sale of 1802, and the second, a list of academies reporting meteorological data in 1839, including the Oneida Conference Academy contained in Madison County, the very county depicted on the right, with O. Blanchard as the primary observer at this academy in 1838. As we see here, when in 1825, and as we've learned above, when DeWitt proposed that academies begin to measure the weather in newly settled territory, he had already apportioned Cayuga, Mohawk, Oneida, Onondaga, and Seneca homelands to white settlers through land survey, speculation, and the legal apparatus of the New York State Surveyor General's office. DeWitt's proposal for data collection in 1825 hinged on and was part of Haudenosaunee land dispossession and settler dominance in the region. Over the course of the 1830s and 40s, statewide observation opened the geographic range of weather display. It visualized settler territory through quantified weather knowledge. Meteorology also created a specific environmental consciousness bound to numericity and tabular display. So tables were the most popular way of displaying weather data, although there's also a really amazing set of wind roses that are part of sort of like early 19th century and mostly mid-19th century weather data publications. This consciousness was the lattice work of occupation, solidifying what land surveying proposed, that settlers could claim land. They sought to measure, study, and archive land, turning it into a resource. The process of dreaming and building a data culture underscores how science always happens within land relations, as sociologist Max Liboiron has argued of pollution, and those relations are always specific to place. In constructing a data culture that prioritized discrete entities, observers foreclosed other forms of relation with land and self. Data culture attempted to know whether discretely, each element an autonomous actor, though many observers struggled with this when completing their weather data observation sheets. And there's some really interesting stuff in the Smithsonian period and in the New York State Regents period, where observers are sending like pebbles, and another observer sends an insect to the Smithsonian. In the Albany material, observers are sort of like writing longer reports outside of the blocks of the table. And what we see at the Smithsonian, and then also through the New York State Regents, is the folks who are managing the project write back to observers, or they release this report and they're like, listen, you need to stop putting all this other stuff on the sheet because we can't make sense of it. This is not helpful for us in trying to get a sense of the meteorological data of the state. So please stop doing this. They didn't really stop. And they really struggled with sort of the containment of the table as a vestibule for data collection. Early 19th century and mid 19th century weather data collection was key to centering settler pasts, so creating an archive of environmental knowledge and outlining settler futures. So what exactly would these futures hold? My book charts the evolution of some of these futures and picks up questions of science's relation to place and nation state with the rise of meteorological satellites in the 1960s, when data is more formally enmeshed in military meteorological nation state structures. The century-and-a-half-old alliance between meteorological data collection and the consolidation of the nation-state's power was alive and well in the wake of World War II. Across 2 centuries, the development of data collection required constant interface with formal branches of the nation-state, from the Surveyor General's office to the Department of War in the 19th century, to the Central Intelligence Agency and the Department of Defense in the 20th century. From Tyros to Nimbus, and Landsat to Geos, all which are meteorological satellites developed from the 1960s on, satellite meteorology dominated weather data collection, collation, and visualization from the mid-20th century to the early 21st century. The development of the Tyros satellite was initially imagined as a military reconnaissance meteorological project. And specifically, I've been interested in the ways that settler satellite data served the colonial ends of international warfare while also exacerbating resource extraction and climate catastrophe. All of this is part of data's genealogy in the mid to late 20th century. The power of data as an extractive tool is a story that begins with collaboration and satellite data resource sharing between NASA and the oil and gas industry through Landsat, a satellite many of us may have heard before. It's a satellite that dates back to the 1970s, and it's a satellite that was really only possible because of its predecessors, Tyros and Nimbus, which were both meteorological satellites. Despite their historical connection and contemporary ties to military reconnaissance, defense, and natural resource extraction, Tyros, Nimbus, and Landsat were largely demilitarized satellites. Their data did not appear through the military apparatus of the satellite's creation, but through an aesthetics of remoteness and abstraction. This allowed and emboldened a weather data culture in which nation-state technologies for reconnaissance, resource extraction, geophysical domination, and data itself became eternal bedfellows, though they rarely announced themselves as such. In 1964, 4 years after the successful launch of Tyros, NASA's first weather satellite, whose origins lay in military reconnaissance, NASA launched another satellite called Nimbus. Nimbus was concerned primarily with providing atmospheric data for improved weather forecasting. So both Nimbus and Tyros were weather satellites. But there was an addition of an experimental sensing device on Nimbus, and that allowed this weather satellite to be used in fields such as oceanography, hydrology, geology, geomorphology, cartography, and agriculture. In its early life, the Nimbus satellite played an experimental role in resource data acquisition. It also bridged the divide between sensing meteorological data, which was specifically related to atmospherics, and the sensing of Earth data or terrestrial data, which was categorized as resource data. Nimbus was an outgrowth of Tyros, and there's a lot I could say about Tyros. That's a really fascinating story, but I won't say much more today other than Tyros was the first weather satellite and also developed the technology for Nimbus and was a vehicle that paved the way for Landsat, which was NASA's first Earth-observing satellite with the capability to monitor resources from crops to shale. Landsat, which we see here, was an adaptation of the Nimbus satellite. And you can see how the logic of adaptation was so important for the technological advancement of satellites in the 1970s. Not so much true today. I was just reading an article about how the next meteorological sensing satellite will have sort of completely different technology, this next suite of satellites, than the previous GOES satellites. Tyros and Nimbus sought to visualize the Earth's atmosphere, and Landsat's purpose was decidedly different. It was terrestrial. NASA launched Landsat in 1972, and its colorful maps, as we see here, became really quickly tools for analyzing the state of the Earth's natural resources. The satellite was both fundamentally different from Tyros and Nimbus, yet it was also deeply indebted to the existing data collection technology of meteorological satellites. Developed by RCA, the sensors, for example, were still televisual technology. And in one of the first Tyros articles in the Times, they emphasize that it's motion picture technology that's being used on Tyros that's allowing the satellite to view Earth. So this technology is still functional on Landsat, and it uses a shutter to snap a photo of the Earth. Influenced by a funding crisis at NASA in the early years of Landsat, both NASA and private industry began to imagine the potential use of Landsat data for the extraction industry immediately following its launch. NASA invited 20 oil companies to send teams to hear about the investigations that NASA had sponsored through Landsat, and both Conoco and Chevron expressed interest in collaborating on research projects. NASA needed to drum up interest in Landsat data from the oil and gas industry in order to keep the program running. They were running out of money. Oil, gas, and mining companies also stood to gain, and to gain quite a lot, from Landsat data in locating deposits. The partnership between NASA, oil, and gas would ensure a new subset of data users and the quick growth of sales and profits for Landsat, thereby justifying the project. The collaboration between these parties was challenging because petroleum exploration was almost always proprietary. The extractive industry kept use of Landsat data a secret so as to protect new methods of analysis and information from being studied by other competing companies. NASA data, on the other hand, was intended to be public. And so if oil and gas companies worked in an official capacity with NASA, their research results would have to be made public, which is what brings us to the joint NASA Geostat test case project initiated in 1977. This was a government and privately funded study of Landsat and meteorological satellite technology in the discovery of hydrocarbon seepage. In 1976, a year before this project commenced, private industry formed something called the Geostat Committee, and membership was restricted to a group of oil, gas, and mineral company representatives, including Exxon, Gulf, Chevron, Mobil, Shell, and Texas Gulf Oil. They all had an expressed interest in remote sensing application for oil, gas, and mineral extraction. The committee's objective and its desire to access raw data from NASA space satellites ultimately led to this research collaboration between NASA and the Geostat Committee, in which the utility of remote sensing technology for geological mapping in general and resource exploration in particular was tested. Remote sensing data were acquired over 8 test sites that were already known to contain deposits of copper, uranium, and oil and gas by using laboratory spectrometers, so some new spectrometers, but also airborne scanners, orbital sensors, and multispectral imaging techniques. Key to the joint project's study of these test sites was remote sensing data from NASA's Landsat satellite. And these technologies, the radiometer, airborne scanners, orbital sensors, these are all technologies that were really born of TIROS as a weather satellite and also its early history as a reconnaissance satellite. The project utilized Landsat's multispectral scanner data in digital and photographic form. And most importantly, it addressed how well 2 experimental scanners would work for visualizing resource data. Test sites were chosen based on existing knowledge of deposits of copper, uranium, oil, and gas in order to reveal whether existing meteorological satellite technology could successfully locate such deposits for oil, gas, and mining industries. The Jet Propulsion Laboratory was utilized to process and enhance images, so that was kind of the data collection and processing center. And then these images and the data associated with them were shared with the investigative team, which was composed both of the Geostat Committee, so members from the oil and gas industry, and then also folks at the Jet Propulsion Laboratory and others from the satellite division. It turned out that Landsat's technology was fruitful for locating petroleum deposits. And while remote sensing techniques had previously been used for structural mapping of the Earth, the test project aimed to use these techniques to detect surface manifestations of hydrocarbon and to demonstrate the efficacy of multispectral images or Landsat sensors for the detection of this hydrocarbon. The project confirmed that a new experimental scanner, the NS001 thematic mapper, was more useful than Landsat's current scanner. And in 1982, with the launch of Landsat 4, this new scanner was implemented into the Landsat satellite. So Landsat technology had been successfully upgraded so that hydrocarbon data and other Earth resource data could be captured through NASA technology. In 1979, Landsat was transferred to NOAA, and with the Land Sensing Commercialization Act of 1984, the Landsat system was commercialized. At the same time, the company that owned Landsat wanted to commercialize weather data as well. That did not happen. There was an additional act that prohibited the sale of any part of the meteorological satellite system to private industry. And so satellites and the data that they collected remained non-commercialized at the time. And this, in my research, really raised another moment. There are some moments from the 19th century too, where data is this, there's this kind of crisis moment where data can sort of either become a proprietary good or stay sort of as a public good, weather data in particular. And I think Landsat shows us the way in which that was becoming a troubled area in the mid-century. Weather data, though at the time, it did not become commercialized. It was just as valuable as resource data, as this data regarding hydrocarbon seepage. It was a commodity within the private sector and was of interest to oil and gas companies in a way that was similar to Landsat data. By the 1980s, NASA had launched 7 Nimbus satellites as well as over 28 satellites under the TIROS program. And the data from these satellites, because it was public, it was also available to private industry for use. And that meant that meteorological data could be used in other ways. For example, by petroleum jobbers. Jobbers were purchasers of refined fuel from refining companies, and they would sell that fuel at retail price, relying on temperature prediction to anticipate a consumer's need for fuel, their need for delivery of fuel. Offshore oil and gas operations relied on private told you this would get to be a tongue twister, relied on private meteorologists for wind and wave forecasts, as well as for forecasts to inform when they should move their rigs. So you can imagine how extreme weather becomes really important for rig operators, and that's just sort of one facet of this. Just as land-based settler weather data collection facilitated Haudenosaunee land theft in the 19th century, the utilization of satellite data for the proliferation of oil infrastructure has directly impacted the experiences and land realities of Indigenous communities in the 20th and early 21st century. Landsat satellites, for example, have been used to execute conceptual site plans as well as habitat and impact assessments for oil pipelines. This includes Keystone XL, Dakota Access, and Line 3. For the Dakota Access pipeline, which proposed to cross the land of the Standing Rock Sioux people, the company geoengineers utilized Landsat 8 data via Google Earth to execute conceptual site plans and profiles for the project. The Keystone XL oil pipeline utilized Landsat data to perform habitat assessments to affirm pipeline viability. Keystone XL's proposed path crossed the homelands of the Great Sioux Nation and the Gros Ventre and Assiniboine tribes. Line 3 utilized satellite data for an impact study assessment of the pipeline route that passes through the land of the Anishinaabe. Satellite meteorology sits at the end of a two-century drama of the U.S. settler states' utilization of weather data and weather data technology toward world-building ends. Meteorological satellites and their data products restructured the vision inhabitants of the nation-state had of themselves, the weather that surrounded them, and the nation they belonged to. The data culture of the 1960s and on prioritized 24-hour data streams and constant access to satellite data meteorological products. And this is a story that kind of goes back to the early 20th century and kind of the late 19th, when self-registering and automatic instruments became really popular at the Weather Bureau. Yet the visual products that circulate as satellite data encourage environmental narratives that remove the situated and haptic body from weather and storm crises. In many ways, the conceptualization of weather data has reached its logical conclusion now that it can be formulated as separate from the settler body. In addition to this, meteorological satellite data became a central part of how the nation state saw itself and its inhabitants, as I've mentioned, and this kind of the focus on vision with meteorological satellites and sort of vision as central in how inhabitants see themselves is a really important thread in the end of toward the end of the book. By the end of the century, from Tyros to GEOS, which is a satellite I didn't talk about a lot, but it's a contemporary satellite that does a lot of our weather data collection currently. The overabundance of data has made little difference in communicating the depth and the severity of the problem at hand. The data documenting the climate crisis did not have the power to save the world, as many in Western science imagined it would. Visual data present a disembodied, abstracted version of the human with respect to weather in general and weather crises in particular, whereby historical relationships of domination, theft, and abuse are absent from the storytelling of environmental crisis. This dislocation is both a feature of settler weather data culture and a crisis that threatens the capacity of settler science to reimagine itself beyond its current system thresholds. So what about the reimaginings? The weather unsettles us, and it is deeply unsettling. And all of the data in the world has not come to save us, because what's needed is not necessarily more data, but a new relation. Over the course of 2 centuries, data functioned precisely as it was supposed to, and it continues to do so across various climate crises. It extracts the US settler state as an actor in the national and global horror of an avoidable climate change. It absolves responsibility for crimes in the name of objectivity. As one ending to this story, satellite vision accelerates the accumulation of settler property and control, which began in the 19th century. Yet at the same time, the weather crises that satellite vision attempt to document, crises accelerated by the uneven and unpredictable effects of global warming, are also destabilizing events within settler colonial timelines in that they challenge settlers' capacity to quantify and claim the biosphere through prediction and data production. So this is sort of what happens when the data gets it wrong. Data does not simply attempt to explain, as many have argued. It also attempts to claim. The nation state's claim to know the land and seek to dominate it through data collection is its progress and peril. Through data, we have made an archive and an atrocity of the weather. We claim to know the biosphere through numerical capture, yet fail to know the same biosphere any other way, especially in vulnerability and need. We refuse to know the biosphere as a network of living beings, each with their own reason for continuance that exist outside of and often against our own desires. How do you escape, or maybe just live under, the particulate matter of ugly weather and ugly data, of the emptiness of a settler relation, atomistic at its core? Maybe we need to let the weather mix everything up, including us. Thanks so much for being here.
Sara, thank you so much for that talk. That was incredible. I feel like reading the book and then hearing it in your own voice, it just makes it all the more alive and pertinent and timely. So thank you. I'm about to open the floor to questions from the audience. We do have a microphone that will be run. So if you can raise your hand, the mic will come find you. And I'm sure Sara is happy to take questions. Yes, we can start here.
I don't know if this works. It works. Okay. Thank you so much. That's so important and wonderful, the way you flip things in my mind just now. And I want to ask a contrarian question, perhaps, which is if you ever come across in your work the way people conceptualize of the benefits of satellite data for agricultural inputs and the change that it can make in predicting droughts or cycles of water in the land. I was just in your planetary science department the other day, and I heard a student that apparently works on that. And she said, well, farmers are so stubborn. They don't want to do what we tell them is best for the land. And that kind of shocked me as a thing. And I wonder how people see different benefits of this technology besides not just resource extraction, but also kind of like management of water and other things in crops.
Yeah, thanks for asking that question and just raising that area of inquiry. It reminds me of some of the research I did for the book in the Dust Bowl period. So this isn't quite a direct answer to your question, but the Dust Bowl period was really interesting to me because it was kind of a failure of a moment to effectively quantify what was an agricultural crisis, like a crisis of soil use and management. And I think what is interesting about that period that does perhaps speak to your question is that some of the most valuable data was coming from cooperative observers who were almost all from farming communities who were on the ground. And so they were taking land-based observations related to the dust storms and were really connected to this crisis. And in fact, some of the upper air data that was collected by the federal government at the time really didn't speak to them as much as this on the ground data. So that kind of resonates with some of what you've brought up. I think there are so many uses for satellite data. Part of what I was interested in was the way that weather satellite technology was kind of like a framework technology for the evolution of many different kinds of satellites. So Landsat data is very important for agricultural communities. I don't know that I can comment so much on the stubbornness of farmers, although I actually am from a farming community, so perhaps I can, but I won't in this moment. But I think that your question kind of raises how there are actually many different kinds of ways that we connect with the weather and that folks connect with the weather that may not be numerical. And farming communities certainly have a sort of numerical and kind of extra numerical relationship to the weather. Should I call my phone? Oh, the mic.
Thank you for your talk. I was especially interested in the sort of first section of the talk when you talk about how meteorological data collection was combined with settler colonialism to justify land repossession and possession. I was wondering if there was any evidence, especially if it was like written evidence at the time, that these meteorologists were actively, consciously trying to use the expansion of these weather networks to claim land, or if it was treated as more of a, oh, because we're expanding into other places, we should start collecting data there.
Yeah, there is actually a great bit of evidence around that with relation to Army forts. And I don't document that deeply in the book, but there's a lot of additional work that might be done around weather data as strategic data in the movement of troops in the early 19th century and the late 17th century. Part of the challenge in working with that material is that it's not all available or saved. There's a really great project, it's called the Forts Project, and they document the history of weather stations across the continent, and then also attempt to provide some dates for them so that we can kind of get a sense of like what were the earliest stations. And perhaps unsurprisingly, some of the earliest stations are at Army forts. There's this other narrative as well from 1812 where medics at forts were asked to keep weather diaries. And so this is kind of one of the first numerical ventures through the Army to collect weather data as strategic data. They were really interested in weather data and its relationship to disease. And so, to me, that seems like a very obvious way in which numerical capture related to the atmosphere was used to keep people sort of healthy enough to continue to expand. Yeah, thank you for asking that question.
Hi. What a great talk. So helpful and interesting in so many ways. I'm wondering about your thoughts on bringing your analysis into sort of an international and neo-colonial perspective. I'm thinking about my own experience, and from 1992 to 1995, I was a 20-year-old research assistant using Landsat satellite photos that was funded by NASA and EPA. We had these huge 4 by 4 foot infrared photos of Brazil and Southeast Asia, Thailand mostly. And then in regular increments, every couple years, we'd go back and redigitize the photos, right? So we'd see year 1, it was a pristine infrared red forested photograph, and then the next sequence would have a line for a road, and then a fishbone pattern of as the road network got built out, and each subsequent photograph had this deforestation that was happening. And we take the polygons, because I was like tracing the shapes of these things, and the polygon shape compared over time measured the carbon input into the atmosphere. But it seems like there's a lot of cultural work that I was doing as a 20-year-old, this. And so it'd be really interesting to hear your perspective on that.
Yeah. Well, first of all, thank you for sharing your experience with working with Landsat data. I think that's illuminating in how truly pervasive satellite data is, and how it is utilized for many different kinds of projects. As I heard you speak, what I was reflecting on was that, first of all, yes, to thinking about this more through an international perspective, but also kind of pushing into that through like the notion that we always need the specificity of place when we do this work, because I think that I'm constantly trying to resist the urge to be as sort of bird's eye as the satellite data like wants me to be. Not that I don't think that's useful. It is really useful in some contexts, but I think when we're dealing with climate change, for example, deforestation, these things that are deeply affecting the lives and livelihoods of not only the communities that are near these places or are enmeshed in them, but also like all of the other biological life that matters for being alive. I am constantly trying to return to like understanding that I'm looking from above, but also that there might be a way to kind of move from below. And so thinking about Max Lebrun's suggestion that an argument that science always happens in relation. And so what are the relations that are possible to evaluate, to see from satellite data, and or what sort of relations do they point to that we might need other ways of sensing? Yeah, thank you for that.
Yes, thank you so much. It was really wonderful to get a sense of your work, and I can't wait to read the book. I had a question about the 19th century and the kind of citizen science moment, and I was curious if you had more that you'd be willing to say about the extent to which the recruitment of volunteers to deliver meteorological data, that in that recruitment there was a certain kind of socialization of a notion of what data is and its relationship to the nation state and its future, and just how overt that was in certain respects, or whether it was all sort of implicit. And anyway, I'd just be curious to hear anything more you have to say.
Yeah, thank you. I could talk about the 19th century for quite a long time, so I will keep these comments short by saying that the Joseph Henry, who's doing this work early in the century, it was so fascinating to chart his work with meteorological data because he's in New York State, like computing these averages from across the state. And then he eventually goes to Princeton for a job there, and then finally the Smithsonian. And he's really, when he arrives at the Smithsonian, the first project he takes on is this National Meteorological Project. And he publishes ads in newspapers, sends letters to farmers, and is like, are you interested in weather? Are you interested in collecting data? Because if so, let's write to me, okay? I will send you what you need, and you can be a part of this national project. And it turns out that most people were really excited to be part of a national science project. And so to me, what that suggested was that it was not just about sort of like tinkering with instruments, although for some people it was, but also the social life of science as a nation state project. And so the correspondence are really fascinating from that period. I would say, though, that I'm not sure that Henry was as commanding in his understanding of what data was as DeWitt and Beck were at in New York. He and the folks that worked with him were really interested in what volunteers brought to the table. And so I would say that they were sort of co-creating the sense of what data was in the mid-19th century. Interestingly, conversations around climate they didn't mean the same thing that we mean today around climate. It was really kind of like regional variability, but climate figures sort of heavily into what data was or what it could be. And yeah, I think Henry is actually okay with like the bugs that are sent and the stones, but some of the other folks who are working for the project at the early stage are sort of annoyed with the vast amount of material that's being sent into the project. But Henry ends up sort of like taking everything that the meteorological project captures and then building out other aspects of the Smithsonian, other aspects of its collection and its scientific work. So I am really fascinated by the way that you know what I mean, how the weather data collection at that time sort of becomes a container for other curiosities. And it's able to do that. Henry allows that, and volunteers love it. I don't know if I answered all of your question, but I really appreciate it. Okay.
Thank you so much. Such a wonderful vision into modern science. Because I work on the 18th century, I know the earlier history of a transition from using the body as an instrument to using the instruments as instruments. And I just wonder if in this material that you're examining, you see traces of that, or is at this point the body as an instrument just gone?
It's not gone. Thank you for that question. There's a really wonderful circular that Joseph Henry sends out to some volunteers, and in it, some of the one turn of phrase in it is data collection as measuring the face of the sky. So there's this way that thinking about measuring different parts of the world in a weathery way meant also anthropomorphizing it, or them. And also James Espy really loves to use the body to talk about weather measurement. He has this moment in one of the Franklin Institute journals where he's talking about viewing clouds and taking some notes around cloud cover and type. And it really is about instrumentalizing the body as a kind of compass for geolocation of clouds. And also because Espy is in Philadelphia at the time of the Franklin Institute, his reference is very city-based. He also kind of employs the city as a way to think about cloud observation. So he talks about sort of like the tips of buildings and like the movement of the head. So it is really there in the early 19th century. I think that it goes away It sort of dissipates toward the end of the century, and certainly by the early 21st century, in the Weather Bureau, the body is sort of like this, it is an excess. It is also something that causes error. Although that's really hilarious because all of these automatic and self-recording instruments are managed by people.
Hi, thank you for your really rich and interesting talk. I am curious. I read some of your book and you treated some of it in the talk, but if you could just entertain a very broad question about how you think about data in comparison to like a case study, the idea of atomization in a data where a table is looking at multiple factors and often some notion of place. And I just wonder how that differs from other methods of research or study where there's necessarily an exclusion of certain dimensions and factors.
Yeah, that's a really wonderful question. I guess I would say that I think also that the table does have exclusion. And so I'm not sure this is directly answering your question, but I think in my work, I had kind of always thought as the table as exclusionary. And in a lot of the letters that I look at from the early part of the century and kind of like a little bit into the Smithsonian period, it's very clear that observers thought that too, that it was exclusionary. And so part of what was really interesting to me when I started with this project was sort of like what is happening outside of the lines. But I think, again, the Dust Bowl period data work really helped me understand that in all of their efforts to standardize and kind of get rid of the stuff that oozes out of the edges of a data table, and like that messiness of relation that is sometimes linguistic, but also sometimes signified in a pebble or a drawing, that was sort of like came alive again in a moment of crisis. So did that get at your question, or do you want to ask a little more again? Okay.
It's all very interesting. I guess I think that got to some of what I was curious about. Thank you.
Yeah. Thanks.
Sara, I have a question. Just maybe to close us out, because you have given us so much to think about already. I'm curious how this project evolved and shifted as you worked on it over the years. I think it's been such an incredible pleasure to read articles of yours that now I see being enfolded into this larger book manuscript and argument. And as I was reading your book, I kept thinking about the strands that I could recognize and then the strands that felt new. And so I'm curious for you what the large shifts were, but especially at what point settler colonialism as a really crucial framework and a commitment to think about that began to permeate the project, or whether that was there from the beginning.
Yeah, thank you for that. This project, I feel like actually started in my poet brain, and then I finally realized that like this was not a poem, or that I could use that like my poetry brain to do this other work. Also the Smithsonian let a poet into their institutional history division. So that was just an amazing process. And I think I really did need to access that frame of mind, or how I think about poetry and trying to ask the questions of the past here. So that was kind of how the project started. And I think your question about like the framing of settler colonialism in this, I think, is really thoughtful for me. when I was at the Smithsonian there and kind of reading the historical work that had been done on this period, and especially the Smithsonian Meteorological Project, a lot of the framing is that this was really the first national democratic science effort in the US. And so I think it took some time for me to be curious about like what was around the edges of that suggestion. And so I think my framing kind of changed after I had a little bit of space from that research. And especially in the second chapter that's really about the Smithsonian Meteorological Project, at the beginning of that work, I thought to myself, wow, there are all of these white women who are participating in science, and that is incredible for this moment in history, both in the field. So there were self-identified women volunteers, and then there were also a group of women who were calculating data in Easton, Pennsylvania. And in the beginning, I was like, these folks are showing me this story of success in sort of breaking into meteorological science. And then as I moved more with the story, I realized that actually they had a more complicated role, that they were both doing this thing that was uncharacteristic at the time of participating in a dominantly masculine scientific practice. Yet at the same time, they were upholding these systems of violence, from settler colonialism to many white women observers in the South who were participating in systems of enslavement. So they're, recording the weather, really like enjoying their leisure recording, contributing to this national project while also disenfranchising Black communities. So I think what I have learned is that no historical actor is necessarily either all good or progressive or all bad necessarily. So that was something that evolved for me throughout the work of the book. I think the last thing I'll say here is that I did struggle, and I still am thoughtful about kind of the language of settler colonialism and like what work that is doing in the book. And it seems to me that the term is sort of, it's kind of emptying. And I feel that in the book, and I think it's true. I mean, it is a term that empties of relation. Mm-hmm. And so, I think I'm still grappling with that and thinking forward with that in the work that is in my future. Yeah, thanks for that, Sara.
It's a beautiful place to end. I want to say, Sara, I feel like you're thinking about writing stories where there aren't clearly like progressive or clearly malevolent characters. And I think one of the beauties of this book is that we get this really full portrait that allows us to think in much more nuanced terms about data and about people and about the environmental future we all face. So I just really want to thank you for your work. Please join me giving a round of applause.
Thanks to you all for being here.